Welcome or welcome back and C squared. In this lesson we'll talk about how to prove triangles congruent by using two more ways. The first way to prove that two triangles are congruent in this lesson is what we call angle side angle congruence postulate, or simple ASA. And it says here, if two angles and included side, very important, included side of one triangle are congruent to two angles and included side of the second triangle, then the two triangles are congruent. Let's take a look on the picture here to see what I meant. And you notice here we have let's start with the angle. Angle A congruent with angle D, and angle B congruent with angle E. These are the two corresponding congruent angles. Look at here. The sides that are congruent are between the angles. They are included. And you see that here also in my conditional statement. This is what ASA congruence postulate is about. So now let's see an example like this one, where we have to say what information is needed to prove that the triangles below are congruent using ASA congruence postulate. So let's take a look. What do you notice? We have angle A and angle M here. Angle A congruent with angle M. We have angle C congruent with angle T. They are marked the same, by the way, if you don't know why they are congruent. Okay, so these are the two corresponding congruent angles. So we need one more part, this side, but not any side, the side between these two angles included. So that will be AC and MT. AC needs to be congruent segment AC, so let's be sure congruent with segment MT. Then by angle side angle, we say triangle ABC. Let's say we start with ABC, congruent with, and now you want to be sure on the second part of the congruence statement, you write the corresponding letters. So which one correspond to A? And that will be M. Right? We notice A and M are together. Which one correspond with B? If you take a look, B will correspond to N. And to C, we can see in the statement before the last one is T. Okay, so this is for this example. A very similar example, however, now we notice these two triangles share a common vertex. So the same thing, what information is needed to prove that the triangles are congruent using angle side angle congruence postulate, and then we need to write a congruence statement. And what do you notice here? We notice this angle L congruent with what angle? E. This angle S congruent with this angle D. So now we have the two angles in this ASA. We need the side included. That will be LS and DE. LS congruent with DE. That is the information we need for using ASA to prove congruency. Now let's write the congruence statement, and let's say you say triangle VSL. VSL congruent to what triangle? Okay, so now what letter corresponds to this V in the first statement? Is also V. One letter corresponds to the S. We see above here that S and D goes together, and L goes with E. So very important to write the correct congruence statement. In some cases, I said here, triangle share common side. But again, the same thing. We want to see what information is needed to prove that the triangles are congruent by using angle, side, angle postulate, congruence postulate. Okay, so let's take a look. What do we notice? We notice we have these two angles are congruent. Now, in this case, I'm gonna have to use three letters, right? Because they have the same vertex. And we have angle ABC congruent to angle DBC. Okay, but then we notice this common side. I said they have common parts together. And we say here BC congruent to itself, BC. That is, if you need to write a proof, what we call the reflexive property. So we have an angle and a side. You may want to even write something like this, so you know what you have. What do we need? We need another angle, but not any angle. We need the angle that make this side included between, and that will be these two angles. Don't call them just C, because that will be confusing. You need to use three letters like we used in the first statement. So it will be angle ACB needs to be congruent to angle DCB. Okay, and that will fit this angle side angle pattern. So by ASA, triangle BCA, let's say you say like that, congruent to what? Now the next statement is very important, right? We have to have the corresponding letter, so it's gonna be BCD. Okay, so remember, this is the part we need. Okay, the information we need. Okay, so let's move now to another way to prove triangles are congruent, and this is the last way. Angle side congruence theorem, or the short way we say AAS. Okay, and you notice in this picture what we have? We have these two angles congruent, these two angles congruent, and then the next thing is a side that follows one of these angles, in this case the angle that is marked with two arcs. Okay, and then we can say the triangles are congruent. So let's take a look how we use this criteria to prove triangles are congruent. So a very similar problem. What do we notice here? We have angle A congruent to angle M. We have angle C congruent to angle T. So we have the two angles in angle side. Again, you may wanna, if that helps, we have the angle, we have the angle. So we need the side, but not any side. We need one of the side, and we have two choices here. We can say BC congruent to NT. That will be option 1. Or can we say another way? Yeah, you may want to say these two guys, AB and MN. So yes, in this case you have two choices to use angle side. Okay, and we're gonna have triangle ABC congruent to what triangle? MNT. So again, two choices here. We can have this. We can have this information which will follow the. We will accomplish the pattern angle, angle, side. But also we can have this choice. Let's move to the next example. Very similar. We had this picture before, but now we want to use the angle, angle, side. So again, we have these two angles congruent. We see that in the picture. Angle L congruent to angle E. We see angle S congruent to angle D. And we have the two angles in these patterns, angle, angle, side. What will be the next thing? Again, we have two choices, like in the previous problem. We can have this side VS and this side VD. So by the way, let's do what we did before. Maybe that will help you have the angle, and now the side in the pattern will be option 1, right? We have two options here. VS congruent VD, or we can have these two congruent. It's gonna follow the same pattern, angle, angle, side, and that will be LV congruent to VE. Now on this problem, I would like you to be very careful. But let's finish this. By angle, angle, side, we have triangle, and like I said, you can start anyway the first part. So let's say you say LSV. That's okay, but now on the second part you need to match the corresponding letter. So which one will be with L? That will be E, right? Which one will go with S? That will be D. And obviously the last one will be V. Okay, so we have two choices here, two ways to use angle, angle, side. Okay, and let me mention something here I didn't mention in the previous problem. If in your mind is, hey, but these two angles are congruent by the fact that are vertical angles, then guess what? You can write some other ways to use angle, angle, side. But I use what is given in the picture. But don't forget, sometimes you can assume things in geometry like vertical angles are congruent. Okay, so very similar. Now we have that last choice, I guess, where we have common side, right? So we have here, like you know by now, these two angles are congruent. We see them in the picture. We need to use three-letter angle ABC congruent to angle DBC. Okay, then we have this side, which is common side. So we have an angle, we have a side, the common side, BC congruent to itself, the reflexive property in case you need to write a proof. And we need another angle, but not any angle, an angle that will fit that pattern angle, angle, side. So that can be only this one, right? Because you see we have angle, we can have angle, angle, and side. Then we have the same here, angle, angle, side. So that will be the information needed to fit the pattern, the criteria. Angle A congruent to angle D, and then by angle, angle, side. Okay, by angle, angle, side. So yeah, here the order is angle, side, angle, but in fact it's angle, angle, side. If you take a look to the picture, these two triangle. So triangle, let's say now you say ABC, because you can start anyway, congruent to what triangle? Triangle DBC. Okay, and that's it for this example. On my last part of this lesson, we're gonna write some proofs. Okay, so we're gonna do the whole things now, beside looking to criteria to prove congruency. So write a two-column proof. I'll do a two-column proof here, and you can try to do a flow chart. Okay, so if you remember, a two-column proof, it's something like this. On the left side, you're gonna write statements. On the right side, you're gonna write reasons. Okay, and you always start with what is given. Angle B congruent with angle T. That is given. But now, first of all, I should have tried to see how we can prove these two triangles are congruent, right? So let's mark on the picture. Angle B congruent with angle T. Okay, that's good. But now we're looking to this segment, so we finish with this. With this statement, segment AR, which is this guy, goes from A to R, right? Bisect BT. Bisect BT, this guy. Bisect means cuts in half. So on my picture, I will show by that thing by just marking these two parts congruent, right? Because that's the meaning. Bisect, cuts in half, those two segments BV and VT are congruent. So what else we need to prove these two triangles are congruent? I think we can see something here. Let me mark that to red. We can assume, if you remember, that these two angles are congruent because these are vertical angles, right? The picture allows us to assume that. So that will be an angle side angle, if you notice the pattern. Okay. So now the only thing is I'm going to try to put all these rough draft, or everything I have in this picture, in the proof. Let me go back to the blue to be consistent. Okay, so we start with the angle, right? I'm gonna put it here. You don't have to do that. So this will be, let's say, this guy, right? So now we need to do the other two parts. Can I start with what? With these two angles, the vertical angles? Why not? We're gonna say angle BVA congruent with angle TVR. Okay, so this will be the second part, this angle in angle side angle, right? And this is the what definition of vertical angles. So I'm going to put here just vertical angles. And now we need to come with this side. But first of all, you cannot just put these two parts are congruent. You have to put some other statement, which are AR, the segment AR bisects segments BT, and this is given, right? It's right there at the beginning of the problem. And now we're gonna write that statement which says BV congruent with TV. Well, what's the reason here? Definition of bisector. Okay, and that will be the S in that statement if we want something like this, right? So now we notice we have angles, side angles list in my proof. Let me erase them now, and now I can write the last thing. Last thing will be exactly what we need to prove. Remember, you always finish with what you need to prove. So the first statement, the last statement should be the easiest one in case you need to fit in a proof. And what will be the thing here? By angle side angle, these two triangles are congruent. And like I said, you can take these two column proofs and try to do a flow chart. Okay, so now let's take a look to the next example. On this example, I will do a flow chart just to be sure you see how that looks. But let's first of all do a rough draft. Let's see how we can prove these two triangles TCA and TCB are congruent. So we look in the picture, we have these two angles are congruent. In this case, you see it's shown us, it says here also, but sometimes you have to mark on the picture. Now the next thing, it says TC bisect angle BCA. It's an angle bisector. DC bisect BCA. So that means these two angles, and I'm going to mark them with two arcs because are congruent. That's the meaning of the angle bisector. And what else we see here? Let me change the color here. We see this common part. So if we look here, what do we have? Angle, these two angles are congruent. These two angles are congruent. And then this side. This is angle side. Be sure, you see, this side is not included. So on my flow chart, I'm gonna have to do this pattern, right? So let's see how we do the flow chart. And you start very similar with the two-column proof. You're gonna start with what is given, angle A congruent to angle B. And we're gonna kind of do a box here. And this is the statement and this is the reason. So you see very similar with a two-column proof given, right? So that is the, if you want to put like this, an A just to help you. No, yes, the A, I'm sorry. That's fine. Okay, so I did the first A in this angle side. Okay, now I'm gonna have to go with the second A, but for the second A, these two angles, right? I need to start with this statement. So I'm gonna say TC bisects angle BCA. Okay, and why we can write this? Because this is given, that is the reason. Now, from this guy, we can write the next thing, what? That these two angles are congruent, right? Angle BCT, again, you have to use three-letter, congruent to angle ACT. And what's the reason for writing this? This is a definition of angle bisector. Okay, so we have the second A in AAS, right? We just need a side. Oh, that is easy. Okay, let me write it here, I guess. So, which is what? The TC, the side TC is a common side, congruent to itself, TC. Okay, another box here. Okay, and now what is the reason for writing this? It's called reflexive property. Okay, so now we have the side here. Okay, so look at here one more time. You want to check it. Angle, side. Now, from these three statements, oops, something like this. Let me redo those arrows. Sorry. Oops. So we have this arrow, right? This arrow. And this arrow, something like this, right? Okay, so by these three things we can write the final statement, which is right here, copied only. Triangle TCA congruent with triangle TCB What's the reason for this? Angle, side. Okay, let me erase these things, but again, you may want to do this to help you understand what you have and how you can prove triangle are congruent. So by angle, side, these two triangles are congruent. And that's it for this lesson. If you enjoyed the lesson, don't forget to click the like button and come back on C-Squared for more help. Thank you.